Okay, good morning. Let us start our class. Am I audible? Okay. So, in our previous class, we have discussed about the basic of sight distance and what are the different types of sight distance. And after that, we have also discussed about the stopping sight distance. So, I suppose that stopping sight distance is clear to you. Let us move forward in this class. In this class, we will discuss about the overtaking sight distance. So this overtaking sight distance is also very important. Now that stopping sight distance that was required to stop the vehicle whenever any disturbance occur in the road. But overtaking sight distance is required to overtake any slow moving vehicle. Okay, for that also you need to see ahead of you. Okay, whether any opposite moving vehicles are coming or not. Okay, you need to think about the speed of the slow moving vehicles, and you need to think about the how much acceleration you want to provide to overtake that vehicle. So that total operation is called overtaking operation. So in terms of definition, this overtaking sight distance is defined as the minimum distance open to the vision of the driver of a vehicle intending to overtake slow vehicle ahead with safety against traffic of opposite direction. Okay, this is the overtaking sight distance. Now, so basically, this definition means that the visibility ahead of a driver whenever he intended to overtake a slow moving vehicle safely without any collision from the vehicle coming from the opposite direction. Okay. Now there are different factors which affect the overtaking sight distance. So first factor is, and that is actually obvious thing, that speed overtaking vehicle, that is the vehicle which will overtake the slow moving vehicle, overtaken vehicle, the speed of the or the vehicle which is lower speed, and the vehicle coming from the opposite direction. Now this vehicle coming from the opposite direction, that is also important, because if there is no lane division or no median is there, in that case the vehicles coming from the opposite direction has a huge role in the overtaking operation. Okay, if there is no room is allotted and opposite moving vehicle is there, in that case you cannot overtake any vehicle unless and until there are free space available. Then skill and reaction time of the driver. Okay, if the reaction time of the driver is good, in that case he can perceive the situation very easily and can take that overtaking operation. Then distance between overtaking and overtaken vehicles, that is also important. The rate of acceleration of overtaking vehicle and gradient of the road if any. Okay, so these are the factors. Now we will discuss about this factor, that how these factors are important in overtaking operation. So let us discuss these things with the help of this figure. So suppose this is a road, okay, and this is a two-lane road. So in one direction, two vehicles are there, vehicle A and vehicle B. Now A1, A2, A3 and B1, B2 are the positions of the vehicle A and B in different time frame. Okay, and there is another vehicle which is coming from the opposite direction, that is vehicle C. Okay, and this C1 and C2 are the different position of the vehicle C. Now, if we discuss about this overtaking operation, first let us consider a slow-moving vehicle with initial position of V1. Okay, this is a slow-moving vehicle which is moving in a highway. Now, suppose suddenly another fast-moving vehicle, vehicle A1, comes behind the vehicle B1. Now, as this is a fast moving vehicle, in that case, its priority would be to overtake the vehicle. Otherwise, he have to reduce its speed to maintain a distance from vehicle B. Okay. Now, how this overtaking operation will be taken place over there? So, initially, the vehicle A, okay, whose position was initially A1, it will initially follow the vehicle B. Okay, and whenever it will follow the vehicle B, in that case, it will reduce its speed and maintain a speed equivalent to vehicle B1, and it will follow the vehicle B. Okay, why it will follow the vehicle B? To look for any opportunity to overtake the vehicle B. Okay, so whenever he get that opportunity, okay, and if the opposing moving lane is clear, in that case, what he will do? He then accelerate his vehicle, okay, start accelerating, and he will change the lane. He will change the lane, okay, overtake the vehicle B, and coming to the original lane. Now, in these two cases, uh, whenever this vehicle A is following vehicle B, or whenever it has overtake vehicle A, okay, just at the moment whenever it overtakes vehicle A, in both the cases they will maintain a safe distance between them. Okay, and this is called spacing. So think about your situation. If you are driving in the highway, so you might have any experience of overtake another vehicle. So in that case, what you will do generally? First, you will follow. Suppose one truck is there, and in the hilly areas, the speed of the trucks are very low. So first, you will follow the truck for few moments until you perceive the situation. Okay, now your perception or perceiving that situation, that will depending on your reaction time. Okay, so until that reaction time in this overtaking operation, it is assumed that that reaction time is 2 seconds. Okay, so within that time you will perceive the situation, and within that time you will follow the slow moving vehicle. So suppose in your case, suppose you are following the truck, in that case you will reduce your speed and maintain a speed equivalent to the truck, and you will maintain a safe spacing between your vehicle and the truck. That safe spacing or safe distance is called that spacing, where it is mentioned as S in the figure. Okay, so after that, what we will do? We will just look in the adjacent lane where any opposite moving vehicle are coming or not. If your lane is free, in that case, what will do? Again, you will accelerate your vehicle. Okay, change the lane, and again, after overtaking operation has been conducted, again you will move to your original lane. And again, at that moment also, whenever you just overtake the vehicle, at that moment also, you will maintain a safe distance from vehicle B. Okay, and that distance is also spacing. Okay, and it is assumed that both the spacing are similar or same. Is it clear? The concept is clear? Please let me know whether the concept is clear or not. Okay, so once more. Okay, first we will give one practical example. After that, we will discuss through this diagram. So, if you are driving any vehicle, think about the situation. Suppose you are going to your home or any other places, and there is one hilly area is there. And you know, in the hilly areas, the speed of the trucks are very much lower. Okay, suppose you are moving with your bike or two wheelers or cars, whatever you have. So, whenever you encounter a vehicle like truck, okay, which is moving with a very slow speed, so what you will do? First, you will think about the situation. Okay, so in that case, you just first reduce your speed and you will maintain a safe distance from the truck. That distance is basically the spacing s. Okay, now after that you will look in the adjoining lane and your in front of you to look for any other vehicle which is coming from the opposite direction. If adjoining lane is free, if you can overtake the slow moving vehicle, in that case what you will do, you will start accelerate your vehicle, okay, and you will change the lane, overtake the truck and move back to your original lane. Then again also you will maintain a safe distance, so that distance is also spacing or s. So basically this is the overtaking operation. So from a1 to a2 you will just reduce your speed. Suppose your initial speed was v kilometer per hour or v meter per second. So after you encounter the slow moving vehicle, you will reduce your speed to the speed of the slow moving vehicle. Suppose the speed of the slow moving vehicle is v suffix b meter per second. So in that case, your new speed from a1 to a2 would be vb meter per second. Okay, so after the reducing of speed, what you will do? You will look for any opportunity to overtake the vehicle. So from this position A2, you will start accelerating your vehicle. So here in the A2, your initial speed was VB. Suppose you are accelerating with a rate of a meter per second square. So in that case, you will accelerate, gain some higher speed and again move to your original position. Okay, so this is basically the actual overtaking operation. This is actually, that is from A2 to H3, that is actually the overtaking operation. Now another thing, whenever you are following the vehicle, in that case, what you will do? You will reduce your speed. Now it is assumed that whenever you are reducing your speed and following vehicle P, in that case you will look for any opportunity, and this depends on your reaction time. Okay, so for the calculation purpose, it is assumed that for the overtaking operation, your reaction time is 2 seconds. So if there is no disturbance from the opposite moving vehicle, suppose that lane is totally free, so in that case, it is assumed that you will follow the vehicle B with reducing speed for a time of your reaction time. That is, for 2 second time, you will follow the vehicle B. Okay, and within that 2 second you will move forward from a1 to a2. After that you will gain some acceleration and that overtaking operation will take place. Now if we analyze the distance, So first distance is d1. So d1 is basically the position of vehicle A from A1 to A2 with a reduced speed of vb meter per second within your reaction time. So here reaction time is taken as 2 seconds. So the total distance d1 would be vb into 2. Now after that, what you will do after that, that main overtaking operation will be taken place. So that distance is basically d2. That distance is basically d2. So in that case, the total overtaking operation will be taken place. Now this d2 distance can be divided into two parts, that is b plus s 2s. Now what is this b? See, during that actual overtaking operation, the vehicle A will move from position A2 to A3, but during this time that vehicle B will also move forward and it will change its position from B1 to B2. It is not like that. Whenever you are overtaking the vehicle, slow moving vehicle, that is vehicle B, will stop there and wait for your overtaking operation. It is not like that. Okay, whenever you are taking that overtaking, in that case, that vehicle B will also moving forward. So during that time, this vehicle B will move from B1 to B2. Suppose that distance is B. So your D2 distance is B plus 2S. Now suppose during that overtaking operation, another vehicle from the opposite directions are moving from C1 to C2. So in that case, that distance is D3. So your total overtaking side distance would be d1 plus d2 plus d3. Now see whether it is clear or not, or I need to explain it again. If it is clear, we'll move forward with the derivation of this. Is it clear? Okay. If you have pen and paper with you, just draw this picture. Please draw this picture, because after that derivation is there and that will help you in understanding the derivation. If you have pen and paper along with you, please draw this picture. So within this time, if anybody have any confusion regarding this, please let me know. Okay, so we can proceed further. So as you have drawn the picture, so here remember first moving vehicle is vehicle A. So initially it was assumed that it was moving with a design speed. Suppose the design speed is v meter per second, but after it encountered vehicle B, it has reduced its speed from v meter per second to a reduced speed of VB meter per second. So basically VB meter per second is the speed of the vehicle B or speed of the slow moving vehicle. So as we have already discussed, from position A1 to A2, that is the time when the vehicle A will follow the vehicle B with a reduced speed. So it is assumed that within that time, within that position, that is from A1 to A2, that vehicle A will adopt the speed of the vehicle B, that is VB, and follow the vehicle B. Now, one interesting thing, in the case of numericals or practical problems, suppose the speed of the design speed is given. Suppose design speed is given, but the speed of the slow moving vehicle is not given. In that case, the speed of the slow moving vehicles is considered as 16 kilometer per hour lesser than the design speed. You just remember this is apart from this, you just remember this thing. So within that time, and as we have already discussed that from A1 to A2, the total time taken would be the reaction time of the driver, and in this case, in the overtaking side distance consideration, that time is considered as 2 seconds. That the reaction time is considered as 2 seconds. Now don't confuse this reaction time with the reaction time of the stopping side distance. In the stopping side distance, we consider the reaction time as 2.5 seconds. But for the overtaking side distance, that reaction time is considered as 2 seconds. Now this thing we have already discussed. Your overtaking side distance would be d1 plus d2 plus d3. So from your picture, your d1 would be the speed of the overtaking vehicle into your reaction time. Now initially it was written that a fast moving vehicle A traveling with a design speed v meter per second is traveling behind the slow moving vehicle B, traveling at a slower speed of VB meter per second. So don't confuse over here. Okay, because the position that d1 is basically nothing but position a1 to a2. Now in the initial derivation portion, it is written as that the speed of the vehicle A is v meter per second, but whenever you are taking this consideration, in that case you suddenly change this as vb meter per second. Why this is so? This is so basically during that a1 to a2 time, the vehicle A will reduce its speed and follow the vehicle B. That's why you have considered vb meter per second as the speed of the vehicle A. Okay, so your d1 is vb into t, so that is very simple. So d1 into, as t is reaction time and it is equivalent to 2 seconds, so 2 vb. So this is the thing. Now another thing you need to consider, that I have discussed that during that overtaking operation, that before the overtaking operation and after the overtaking operation, the vehicle A will maintain a safe distance from vehicle B. So that safe distance is basically called spacing. Okay, that is called spacing. So this spacing, sorry here, that is incorrect. That would be S. So here the spacing is 0.7 Vb plus 6. So this is a empirical formula and given by IRC. So there is no derivation associated with it. So this is the empirical formula. You just have to remember that the spacing is 0.7 Vb plus 6. Vb means the speed of the slow moving vehicles plus 6. So this is the formula for spacing. Now your d2, as we have already discussed, d2 is b plus 2s. Okay, b plus 2s. d2 is b plus 2s, as you can see from the figure. So now you need to find out what is b. Okay, now you do not know what is the time for the total overtaking operation. Now suppose the total overtaking operation, that the time taken for the total overtaking operation is capital T second. Okay, capital T second. In that case, within that overtaking time, what are the changes made in this portion? So during that capital T second time, the vehicle A will move from position A2 to A3, and during the same time only the vehicle B will move from position B1 to B2. So basically that are the things which have done within the T second, capital T second time simultaneously. Okay, so if the speed of the slow moving vehicle B is Vb meter per second, and if the total overtaking time is t second, in that case you can say that your distance B is nothing but Vb into capital T second. Okay, so B is Vb into capital T second. Now you do not know what is T. So what is the next course of action? That you need to find out what is this T second. Okay. Now, as we have already discussed, that during the T second time also, the position of the vehicle A will change from position A2 to position A3. Okay, so whenever the vehicle was at position A2, in that case, the initial speed of the vehicle A was Vb meter per second. But after that, what will happen? That the vehicle A will start accelerating. Suppose that acceleration is a meter per second square. So in that case, your d2 distance is Vp into t plus half at square. This is a basic formula from your 12th standard. Okay, that basic speed formula. So your d2 is Vp into t plus half a into t square. Now this d2 distance. What is the d2 distance? D2 is nothing but b plus 2s. Now what is b? B is vb into t. So you can write that vb into t plus 2s is equal to vb into t plus half at square. So from that derivation, you will get to know what is t. So t is basically root over 4s by a. So that is the time for the actual overtaking operation. So from that you can easily write down your t2 is 2s plus vb into, in spite of t you can just write down root over 4s by a. So we have also that already derived the equation for this two portion. Now the last portion remain, that is what is the distance from C1 to C2. What is the distance from C1 to C2? Now it is considered that during that overtaking operation only, the vehicle C will move from position C1 to C2. Now as the vehicle C has no constraint, so it is assumed that during that overtaking operation, the vehicle C will move with its design speed only. So if the design speed of the road is v meter per second, so here d3 would be, d3 is v into t, as this distance was covered during that overtaking operation. So therefore your total overtaking distance is d1 plus d2 plus d3. Now look this figure and think about this derivation. Just think about the derivation and let me know your problem faced by you. Sir, why 6? 0.7 VB plus 6. See, basically that formula, that is S. You just remember that is not D1. It was incorrect. It would be S. See, 0.7 VB plus 6, that is basically a empirical formula. You know about the empirical formula. Empirical formula are formulated by extensive experiment. That's why they are called empirical formula. So after the extensive experiment, the researchers came to know there is a relation between d1, that distance, sorry, s, that the spacing and the speed of the slow moving vehicle, and that relationship can be uh, drawn through this equation, that is 0.7 vp plus 6. There is no there is nothing is there that why it is 6, why it is 0.7, like that, because this is the empirical formula. So whatever formula is there, that is only okay. There is no background stories behind this formula. So you just have to remember that your spacing is 0.7 vp plus 6. Now just see this figure and think about all these situations, and think how to calculate d1, how to calculate d2, how to calculate d3. Just think about it, so that you do not have to read after that class. Within that class, that all these things can be covered. And let me know whether it is clear or not. Yes, 0.7 and 6 be constant. That would be constant. Okay, now about the derivation, I'm just simplifying it. First, you need to calculate d1, and that would be easy. D1 is equal to Vv into T, where T is reaction time. After that, coming to the D2. Okay, now in the D2, that distance is divided between B plus 2S. Now the S, formula for S is 0.7 Vb plus 6. That is an empirical formula. Now you need to find out what is B. So B is basically the distance covered by slow moving vehicle during that overtaking operation. So that would be Vb into capital T. Now another thing, that D2 distance is again the distance covered by vehicle A from A2 to A3. So you just use the speed formula, that is your T2 would be Vb into T plus half AT square. After that you just equate both these things and you will get to know what is the capital T, that is time taken for the for this overtaking operation. After that you will find out the d3 by simply multiplying by the speed of the C vehicle, or speed of the or the design speed into the t second which you have got from this b2 distance. Okay, so that is actually the overtaking distance. After getting the value of t, okay, so that d2 distance is basically, as I have already discussed, d2 distance is basically, as you can see from the figure, it is b plus 2s. Now you know the value of s is 0.7 vb plus 6. Okay, now what about b? B distance is the distance covered by vehicle B from position b1 to b2. Okay, so therefore this distance would be, if the speed of the vehicle P is Vv and the total time taken for that overtaking operation is capital T, in that case that distance is Vv into capital T. Okay, so the distance is, see, the distance is Vb into capital T. So what is your total T2 distance? D2 distance is Vb into capital T plus 2 seconds. You just put the value of b over this equation and you will get d2 as vb into t plus 2 second. Now another thing, that during that capital T second, vehicle A has also moved from position A2 to position A3. Okay, now in that case, the initial speed of the vehicle A was Vb meter per second. After that, it will gain some acceleration and move forward and change its lane and overtake the vehicle B and move to position A3. So if the initial speed was Vb, acceleration is A, and total time taken is capital T, in that case, by basic formula, your d2 is Vb into T plus half AT square. Okay, so basically that formula is like that, S equal to Vt plus half AT square. You just go through that formula in your 12th standard. Okay, you will easily get this. After that, you just equate both these two things, that is your d2 is Vvt plus 2s equal to Vvt plus half AT square. So from that you will get the t second. T, whatever t is there, you just get to know about the t second. Now after that, what you have to do, you have to find out what is d2. So you know d2 as b plus 2s, whether b is nothing but Vv into t. So instead of that t second, you just put the value of t, that is 2s plus Vb into root over 4s by a. Okay, after that you just find out what is the value of c1 to c2, and the total distance is your overtaking side distance. Is it clear? Okay. Now, after that we have covered that overtaking side distance. Now, let us discuss another thing, that is overtaking zone. Overtaking zone is, suppose in the highway it is advisable to provide the overtaking side distance. Now, for the overtaking side distance, that overtaking side distance is generally higher than the stopping side distance, and it required a longer space. Now, sometimes in the hilly areas, it is always not possible to provide overtaking side distance in each and every portion of the road section. Okay, so in that case, what happened in the hilly areas? Sometimes the road authority will provide some overtaking zone. Overtaking zone means that zone is designated for the overtaking operation. So for that purpose, the width of the road section within that zone would be higher than the actual road section. Basically, that portion is called overtaking zone. Now there are some specification for the overtaking zone. Like whenever you are entering, a vehicle is entering the overtaking zone, so first and foremost thing is the driver needs to inform about the overtaking zone which is ahead of him. So for that reason, signposts are required. Okay. Similarly, when the driver of overtakes or overtaking operation has conducted, in that case also, at the end of the overtaking zone, the driver again also needed to convey that your overtaking zone is coming to end. So basically, that has been done with the help of signpost. Now, what is the total length of this overtaking zone? So generally, three times. That is, minimum overtaking zone is three times of the total overtaking side distance, and the desirable is five times of the total overtaking side distance, which you have found out from this equation. Okay, now the position of the signpost would be, first signpost would be at a distance of overtaking side distance in the entrance, and the last one, that is the during the end point, that signpost would also be at a distance of overtaking side distance from the end point of the overtaking zone. So whenever a driver is approaching over there, in that position he will get to know a overtaking zone is there ahead of him. After that, suppose some overtaking operation has taken place over there. So after that, whenever he is intended to leave that overtaking zone, again he will be informed by another signpost that his overtaking zone is coming to the end. So basically, that is overtaking zone. Now next is side distance at intersection. So in the intersection also side distance is required. Suppose that is an intersection. So in that case, suppose these two vehicles are approaching that intersection. Now if their view is hindered by local buildings or any other obstruction over there, in that case there would be chances of collision. So for that reason, side distance is also required in the intersection. Okay, so in that case, what happened? Generally, no building construction is allowed over there up to a certain distance from the intersection, and that distance is called setback distance. So this is all about today's class. So we'll start our next class from 10, I think, 10 a.m. 10:15. Okay, 10:15. So You just go through the note. If you have the note, okay, we'll start our next class from 10:15. So same link. You get the same link.